In this video, we're going to be talking about transistors. Right here is the basic diagram for a transistor. It's made up of three parts: the collector, the base, and the emitter. And I like to think of a transistor like a gate or a switch. In other words, if we have some water or fluid right here, it's trying to get through, it's not going to be able to because it's blocked right there. The only way to open this gate up is to send a signal right here that will open up this gate and allow whatever is behind it to get through. Now, a gate can be partially open or completely open. A partially open gate will not allow the full amount of full current to get through. And we're going to talk about that. That's what this chart right here is representing. Because we're dealing with electronics, we're going to have some voltage coming into the base, and that is going to allow the current going through the collector, and that's going to be our IC. And this is the current going through the base. And this graph over here is showing how the current going through the collector is a function of the voltage going into the base. At first, we need to be sure we get enough voltage so that we can overcome that resistance, and that's generally about 0.7 volts right there. And once we hit that spot, we kind of slowly open the gate until we reach right here where the gate is fully open, and then the current is just a function of the voltage source up here and their resistors. And in this video, we're going to show you how to solve for the minimum voltage in to get to the saturated region. So we're going to come down to this basic transistor circuit. We have a voltage source and a voltage that's going into the base, resistors at the collector, at the base, and at the emitter. And we're going to solve for the minimum required voltage going into the base so that this transistor is fully saturated or completely open to allow the most current possible through. So we're going to come up here and look at this point. We're going to set these two equations right there equal to each other because well, that is where that point is. So let's change the color. Current going down is IC. That is going to be equal to beta times IB, which is equal to the voltage source minus the voltage at the collector, all divided by the resistance at the collector, or the resistor at the collector. And what this is this is a voltage drop from this source to the collector region. And dividing it by the resistance of that resistor will give us the current going through the collector. And now we're going to do the same thing we did here, but for the current through the base. That is going to be equal to the voltage in minus the voltage at the base, all divided by the resistor at the base. And that is going to give us the current going through the base. We're going to plug this equation into the top one, and we're going to solve for our Vn. So Vn, and that's going to look something like this. Vn is equal to voltage at the base plus the resistor at the base divided by resistor at the collector times beta, all multiplied by Vs minus Vc. This is all great, except we don't really know what the voltage at this base region is, or the voltage at the collector. And so we're going to simplify those by referring them to the voltage at the emitter. And we're going to do that by setting the voltage at the base equal to the voltage at the emitter plus the voltage that is required to go from the base to the emitter. And again, this value right there is generally 0.7. And the voltage at the collector is going to be equal to the voltage at the emitter plus the voltage required to go from the collector to the emitter, which is generally 0.2 volts. And we can plug those in to our equation. And now we have the problem that we don't know what the voltage at the emitter is. So we're going to do another current equation, or something like it. We're going to solve for the voltage at the emitter, which is simply the current going through, so i.e. multiplied by the resistor at the emitter. And because this is ground, we know that that will be the voltage going through that point. And the current going through E, current at the emitter, is simply equal to the current going through the base plus the current going through the collector. Those two currents combined is equal to the current going through the emitter. Setting all this into our top equation right there and solving for Vn, we can solve it all in terms of the voltage source up top and the resistors and the voltage drops VCE, VBE. And that will look something like this. Vn is equal to VBE plus RB plus RE times 1 plus beta. That is divided by, RC times beta times RE times 1 plus beta. And that's multiplied by Vs minus VCE. And that will give us the minimum voltage required to saturate that transistor.